So this is my Zoom window. There's the chat. So hello everybody. This is Fernando Daguano from Argentina. Thank you very much, Sarlet, for your feedback. So we will be waiting for some minutes for the rest of the crew to join in, but we can start with some introductions. This is Fernando Daguano from Buenos Aires, Argentina. I'm the founder of Alquimétricos. Alquimétricos is a collection of open source toys which are focused in the STEAM field and which are specially aimed to fight inequality in terms of STEAM education. I don't know how things are going in your country, but here in Latin America, things are going quite tough in terms of access to quality education, and especially with those features or fields that are more linked with the technology and the science. STEAM toys are quite expensive, and the knowledge and the base level of the public and even private schools in Latin America for science and technology is quite low. So we need some resources to help with that development, and especially with vulnerable communities, because Alquimétricos especially targets those fields in which STEAM education is more difficult to access and more there are less opportunities. So let's see how's our focus on that. I will turn off my camera for a while, and I will show you a brief presentation on what Alquimétricos is and what we do, and we hope you like it. You can share your thoughts in the chat and make your questions and tell us everything you want to know about our project. Okay, so let's start. This is Alquimétricos presentation, and then we will be seeing why we are doing that in this way and how it is connected to open source STEAM toys. We are an international community born in 2015, a mix of educators, designers, makers, communicators, and people who is in love with the open and the big open, the commons, and everything that has to do with sharing. In these late years, we have been traveling quite a lot, making activities for more than 11,000 children played with us. More than 1,000 teachers were trained in more than 150 workshops, and we have presence now in Argentina, Brazil, Spain, and Portugal, due to the partnership with some friends in there. I would like you to show you a short video showing in the practice what Alquimétricos has to do with. I don't know if you can hear the music from the video. Perhaps Charlotte can tell us. Alquimétricos is a simple concept in which we use a wheel with holes. Perhaps it's a geometry, perhaps it's a round object, but we mainly use the holes. Okay, thank you. We don't have music. Music is very nice in this video. I will send it to you later. Alquimétricos concept is very easy. You get your stick, you put it through the holes, and it gets fixed along with the tightness of the material, perhaps, or you can use a small elastic band to tighten it so it stays that way. The principle is very simple, but it took us through a lot of adventures during the last years in many countries and in many fab labs and many spaces in the maker universe permaculture universe, educational, alternative education universe, and many other things. Alquimétricos hubs are used for connecting sticks, and with the sticks we create geometries, and with those geometries we can create almost everything, or anything. This procedure I will show you next is the output of the Jugueteria hackathon that happened last year in the Media Lab Prado in Spain, in Madrid, which we had the honor to be part of, and I will show you a very short video on that, because it was something very specific, very niche, related, which is toy making, open source toy making using digital fabrication techniques. This is Sara San Gregorio, which is the, I can say, the head of the program. And it was a wonderful opportunity to learn about the history of the toys, the philosophy of the toys, of the childhood, and the sense of playing, and how that influenced the arts, the market. And it was a very interesting experience, in which first part we were like more focusing on studying what was the story of the toys, and the second part we did some more design and production. So I will stop this here because we have a lot of material to see, but I really recommend you to get this jugueteria.org link, and I will share it in the chat so everybody can see that. Here you are. There you are. So Jugueteria, first link I will send you. So enter there and you will see some part of the process in which we got to know each other, got to know the history of the games. And I really recommend you see these charlas here, because you will see and you will hear lots of specialists talking about the story of the games, the toys, and the history of playing itself. It took us through a lot of design experiences and knowledge, connected with how I was telling the history of playing, the history of toys making. And I really recommend you to go through this material here in the Tumblr site, because it has a lot of information on digital fabrication and open source toy making. So I'm very grateful I had the opportunity to be part of that experience. So turning back on what we were doing, last year we had the opportunity to systematize our open source and open knowledge perspective, because we have to do some technical transference to the team that was physically in Madrid, who would be fabricating the actual pieces. So this 8-step process is some kind of summary of what we were doing during the hackathon: the presentation of the concept, the selection and pre-production of materials, this prototyping stage in which using digital as well as analog tools, they were able to experiment with the concept and to see what could be done during the experimentation. The local team got to know the technique, the materiality, the production possibilities, opportunities, and through all this process, which was an iterative process in which after experimentation, you plan a new production and then you make a larger scale production and you face other challenges. There was a play stage, which is more showed up here in this album, which I would really recommend you access and see with your own eyes, because it was very interesting. Because involved mixing every piece of every toy, every system we were making at the same time. So it was very, very funny to play along with. So this 8-step process that ends up with the sharing and the realization, we should be really updating this chart, but allow us to develop this systematization of our proposal, which is how you make educational toys, STEAM educational toys, using the less possible resources, or at least the actual resources you have in your community, the tools, the knowledge, the materials, the infrastructure, the culture that you have in your community. So we made a 4-question graphic, infographic, which allow us to ask you which is the materiality you have access to, which is the kind of stick, the kind of plank or sheet of material you have, with other complementary materials you have, like rigid materials, boxes, electronics, or perhaps you have access to recycled materials like plastic, clothes, textiles, shoes boxes, an old soccer ball, or an inner tire tube. Because based on the materials you have access to and the tools you have access to, but maybe they are handcraft tools, they might be serial analog tools, or maybe in our environment, in Fab Lab environment, digital fabrication tools such as laser cutter, router, even plotters, or 3D printing. You have access. If you have access to one of these, you may be already able to produce your own Alquimétricos kits. And depending on how many kits you are willing to produce, you may be choosing among a variety of processes and tools and materials that combined can give you a specific pathway through this infographic. So this is kind of the output. This is quite the result, the product and sub-products, the scrap that is produced during our process. This is something we really like sharing, which is how you make your own Alquimétricos tools. Then you choose which design, because we have a variety of designs and you can make various kits to achieve different educational or recreational objectives. Then we have other questions like, which is the scale of the structure you want to build? Is it something as small as a soccer ball, or is it as big as a circus tent? We will be like discussing that later, but you have opportunities to fulfill all those needs in this quite simple process. And this knowledge is what we have been trying to share lately, what we have been focusing on. This is another view of the same tool. We have one column that's like this vertically. For each kind of material, you need sticks, you need sheets of some flexible materials. You should be considering new as well as recycled materials, complementary materials, packaging, etc. And then you have the equipment, the needed equipment, and the tooling, as well as the design, and you will have a specific output, which I would like to share with you what was like the output of this process in Madrid along with the Media Lab Prado. The music here is also cute, but I think you won't be hearing it. Those in the video are Andrea and Victoria, which were the head of the team in Madrid, who they are two architects who are also into toy designing techniques and procedures. So we shared this experience remotely. I was working from Buenos Aires while they were at Madrid, getting in touch with the material, and the tooling, and the actual challenges of taking this to life. We experimented with smaller quantity and size of the pieces. Then we went toward this frequency 3 geodesic dome, 3/4 geodesic dome, which was quite challenging, but it was a very nice experience and a way to get in touch with professionals and designers from many places. They are very valorated members of our community. We usually keep talking because we want to keep doing things together. And due to this spirit of sharing and this need to make Alquimétricos available for as much people as possible, especially talking about teachers, because they are the ones that are in touch with more kids and that they need like ready to use educational tools. We designed the website, and this website got funding the last trimester. So we are launching it very soon, and it is called Alquimétricos Lab. It is actually in Portuguese right now, but we expect to be making this multilingual as soon as possible, at least in Spanish and Portuguese, as the rest of our material are. But mainly here you will find a bunch of tutorials that are aimed to show you how to make your own templates, how to make your connectors, which are the prerequisites, which things you need to know before starting building, which kind of tools and materials you will need, how difficult it is, which subject, which is educational curriculum specific. This BNCC is like the K-12 program, you know, in the Brazilian curriculum design, educational curriculum design. So these codes are the reference that specify and justify why we should be doing this at school, and in which way it connects with the program. So it is very interesting that we are proposing something that you can see and make at home as well as school, and we try to give it ready for teachers to take it and to deploy it at school straight away. The music here is also funny, and I guess you should be visiting lab.alquimetricos.com to get to know all we have to offer here. I will pass this link in my chat window so I can share it with you. Here it is. There you are. So this is a collection of instructions on how you can make your own tools, your own educational tools at home, your own STEAM toys, using very simple tools and materials, step-by-step instruction, how to go on learning beyond the limits. And you can be part of this. You can be part of our community. You can reach our community call. I will share it with you later, but you can also access Alquimétricos at Instagram or Twitter or Facebook. Just look for Alquimétricos. We are there in your favorite network, so you can get in touch and get to know our proposal, and you can even download here. I will give you this as a present too. You can download these templates so you can start playing with Alquimétricos at home right away. If you have a pair of scissors and perhaps some barbecue sticks, you can build your own geodesic structure right away today. We even have some Alquibots. This Alquibots project is something like the robotic casting of the Alquimétricos. It is also inspired in the same design principles, and we have designed this detachable stick combo with which you can build a tensegrity structure, and later on you can insert some robotics on those structures. I can show you right here. This is the tensegrity kit 0, which is our star, is a flagship in our Alquimétricos Alquibots community project. It has had some updates because this one was the passive tensegrity, and this one is ready to have some servo motors built in. So you can add, this is the digital fabrication process. We will show some digital fabrication because we are doing this completely without any tool, digital fabrication tool. So I will show you a machine cutting laser, perhaps very bad calibration, but laser cutting in the laser cutter of someone else is always a funny business. So this is some experimentation with the tensegrity and servo motors and Arduinos, and we have prepared some kind of tensegrity family kit in which we have been doing. This is FabLab Lisbon. I really like to share memories from travels and trips made along with Alquimétricos. This is in Lisbon in 2019. Teenagers and parents workshop on dancing tensegrity kits. We wanted to make a robot that was completely useless. It didn't make anything special but dance, and I love dancing and I love dancing robots. So this is the proposal of our tensegrity kits along with the Alquibots kit. So this happens a lot that we don't have a personal and our own Fab Lab, but we have been traveling a lot, and we have been received and invited to be part of activities, for example, here in Cuenca, in Almendralejo, Badajoz, with the Fab Lab Extreme crew, in Lisbon with the Fab Lab Lisbon and the Fab Lab Benfica people, which are amazing, both of them. Viva La Porto. We have been invited to Barcelona. We have been invited to many places in Portugal, Spain, mainly Morocco too. This is something I always want to talk about. This about the friendship in the maker community. You will find always a lot of wonderful people to share technology and great moments in your life. So this album in particular, I want to share it with you. It has a summary of some experiences we have had during the past years regarding digital fabrication of Alquimétricos and non-Alquimétricos kits. For example, this is nothing that we have invented. This is a very classical snapping design of pieces, and we have been experimenting with that for the past like 7 years and making toys. In every Fab Lab we can make we can enter. We love getting in a Fab Lab with a pen drive, or perhaps with when an internet connection, and some materials perhaps we got from home, from the street, or we bought in our local supply shop, and then we get out with a family of kits already completely ready to be used. This this is something I wanted to talk about too. This Fab Lab Cuenca experience was meaningful in many ways. There we built the higher Alquimétricos geodesic extractor we have ever made, and we are very proud that this is something we share with a lot of people in this during this residency week we spent in Fab Lab Cuenca, all of with the Cuenca team, with our amazing people. But something very funny happened, because Cuenca is some sort of the vine capital in Spain and even in Europe. And they produce, they grow and produce and export a lot of this willow vine. I don't know how you call it in your place. Here in Argentina we call it mimbre. In Brazil they call it vime, and in some countries it's vines, and in some countries it's willow. This is for basket weaving, you know, and you can even make furniture and a lot of things. And we use this material to build this structure, you know, and this is something very, very important for us, the fact that we take advantage on what's abundant locally. It's something we spoke about here in the introduction, when we were talking about our transference process. And we were asking, one of the questions we were asking is, what is available and in your country? Material asequible, in Spanish is something like available materials, something you can it's at your you can afford it, you can find it in abundance, you can really count on that material, and it won't be expensive. Perhaps you can cut it in the own nature. You have it growing by the side of the street. It depends on your region, and we try to make things as region oriented as possible. So in some places we use some materials because they are abundant there, and in some places we use other kinds of materials. I don't want to get very lost. These photos are from different processes. We talk about quite a lot about laser cutting. This is plotter, the cutter. This little cutting blade can slice materials up to 1 millimeter, and this process we try to get advantage of each machine we would find inside a standard Fab Lab. You know, like Alquimétricos was born during the foundation of a Fab Lab like shop, which was called Neti. It is actually called Neti. No está todo inventado. Not everything is invented, which is a project we started some years ago here in Buenos Aires, along with other 3 partners. Then I left away and started Alquimétricos, but the matrix of Alquimétricos is based upon those years researching digital fabrication techniques, as well as permaculture, as well as open education and popular education, as well as other disciplines like open source hardware, sharing economy, like trying to connect the dots among a lot of things that are happening at the same time in the world, and trying to use the possibilities of a Fab Lab grade equipment to produce our products as well as our marketing tools like this sign for an exhibition we made in Lisbon, and experiment prototype with our products and with other tools we may use, perhaps to experiment with other kinds of digital fabrication, perhaps to make PCBs and to make circuits. This is a Brazilian implementation of the Arduino family, which is called Franzininho, which I really recommend you follow, which is because it's a wonderful project from Brazil. I don't like much the 3D printing environment, the 3D printing world. I'm just I'm the kind of guy that wants to take away parts of a block or a sheet of material. But we also experimented with 3D printing, and our results show us we can adapt to virtually anything we find inside any kind of digital fabrication workshop, or even not digital fabrication workshop. So what we are sharing today with you is a collection of knowledge, techniques, procedures, and even philosophical principles we follow to make this knowledge available to the people that we think that really need it. And during the past 5 years, we have been developing this kind of tools that allow us to share the knowledge with as many people as possible, as much people as possible. In this template site I share with you, you can download this PDF version of our templates. I would like to stop the camera for a bit, perhaps sharing some other kind of content. I will come back here and I will show you some real life Alquimétricos. Let me stop. This is something that is still playing. So here we are. This is our workshop. This is our the mobile version. As I told you before, Alquimétricos is a lot about enabling kids and teachers with as many educational resources as possible, and this means in a lot of cases that we are fighting against the lack of some resources, some basic resources. So we are very used to work with digital fabrication tools, like the ones we use to produce this connector, this sign and these connectors. But we use a lot of handcrafting tools. This is a punch hole plier. This is my pocket size laser cutter. If I don't have a laser cutter, if I will go to a favela like environment, because I will make a workshop there, I will probably carry a half a dozen of these in my backpack, so everybody can share them. This was pre-pandemic, but I think we will find a way to do it in the next weeks back in the streets. So this is the setup I usually use, and I usually recommend for people that want to start to experiment with Alquimétrico design and don't want to invest much. They don't have to invest much. Just get a pair of these nail cutting pliers that you can find for like $2 in your store. This costs like $3 or $4 in your local stores, and this is another $1. So you have a less than a $10 kit you can use to produce as many Alquimétricos as possible. This is the best thing you can buy if you're a teacher or you work with art or design. and you want to experiment with this. So let's see what's the actual business with Alquimétricos. This is a little structure. It's like some kind of pyramid. We try to make something we can shoot something out of it. It's some kind of catapult, or yeah, it's not a trebuchet. This is a catapult, and I have something very small here. I maybe showing. Yeah, it flies. You can trust me. So how's the deal with Alquimétricos? Well, you have like two kind of things. You have templates. These are templates. These two are pentagonal templates, and these other are hexagonal templates, because you will be making at least two types of connectors. You will be making in a soft material, flexible material like this EVA. Perhaps you can use recycled cardboard from these shoes boxes. You can also use plastic. This is some kind of recycled plastic, like iron. This is my plastic recycling iron, which I use to melt plastic bag layers together. I use a paper in the back and in the front, so I can melt a bunch together. This is a thicker plastic layer, which will be more suitable for this kind of hard template than the flexible connector like this one, which we use here in this icosahedron structure. It is all made out of this plastic bag, and we use a completely handcrafted procedure for this one. But in these cases, we use completely digital fabrication techniques for the hard templates as well as for the connectors. And we can make connectors in any like shape or size. Here you can see the difference between a connector you will use as a hub for like this very thin, like 3mm bamboo sticks, and then you have some thicker, like flooring, EVA flooring connectors that you can make that very big geodesic structure we showed before, that was like 7-meter in diameter, 5-meter high geodesic structure. So there's a lot you can do out of this. Geodesic structures are awesome, are very, very interesting architecture structures to explore, and I really recommend you go that way. But this can be used for many possibilities. Here you have a tool you can use to draw circles. In Spanish we would say compass. In I don't remember how to say this in English. Perhaps you can say compass. Compass is like other kind of tool too. So I won't shoot anything. Let me see. I'm hearing some notifications. Let's see if everybody is there. So okay, here we don't have any notification, any bad notifications. Scarlett, you are my angel. You can tell me anything you want or no. Let me see one other window, if is there anything I should see, and then I go on with my presentation. It is 20 minutes to 7 p.m. here in Buenos Aires, so this will end really soon. I just wanted to show you how's the connection principle behind the Alquimétricos. Something very simple. It's so simple that is lovely, which is you will use bamboo sticks like this to go through the holes. You will have a pair of holes for each axis, you know, and then I keep listening to notifications, and I just want to be sure everything goes by. Okay. So this is the thing. You just connect in the front and take it back again in the front. You go through like half a centimeter, then you put it again. It's quite. It has quite a good grip. Here I'm using a pentagon to connect 3 sticks. It's not the best. It's not forbidden either. I encourage everybody to experiment with the possibilities of the materials. Doing this with flexible materials is very interesting as a construction principle, because we are very used to have like fixed hubs in the architecture, in the industry, and even in the games. When you see Lego and you see Kinex and most of the connection kits, the building block systems, they are quite straight and tough, and you don't have the flexibility to adapt to different angles. And this system, this method, is based upon flexibility, and things are not quite like always straight. Things are, many times they are like pushing a bit, a bit. Don't know how to say tuerto, torcido in English, but things are not quite exact always. So this kind of building is interesting because it is much more intuitive rather than exact. We don't speak of measures here in Alquimétricos, or we speak about like relationships. This is a relationship between this diameter of stick and this diameter of hole and the pressure you make, and this equilibrium is very nice. It has a nice grip. It can like turn, but at the same time resist some tension and pressure, and it still has the opportunity to be flexible. And here you will have a much more a much thicker material, and you can use different kind of sticks. I have a pen here, which is also, this is thinner, actually thinner from the hole. You should use sticks that are slightly thicker than the hole, but it also works because the material is quite has its resistance and grip, so it actually works. It will work much better if you have something thicker, like a 2 centimeter diameter stick, which you can find in the nature. Nature will offer you like canes and sticks, and this works very well with canes. So just to wrap up, we want to share this method with you. Alquimétricos is a collection. We have many systems. These Shades extractors, it's our like flagship systems. We love it. It's completely open source. You can get it and you can fabricate your own kits with your own tools, with the things you have at home, at your school, or at your Fab Lab. You may also use digital fabrication techniques like this we use here, and use a variety of materials, recycled or new. So I will ask everybody to join our community, because Alquimétricos is what it is because of you, because of the people that contribute every time to make our community bigger and better. And I would like to show you where you can access here. We have a collaborators call in which you can register and let me see. I don't remember the English version. So I will ask Google. That's here it is, because Google is smarter than everybody here. So there you are. Some people, Scarlett in particular, thank you for being there until the end. We have Thomas there. I will share. This collaborators call link, because there you can have a sneak peek of what's our community about, what we are looking for, what we need, how you can help, how you can take Alquimétricos to your community. So everybody's invited to join our Instagram too, because there you will be getting to know all our news, and you will, as I told you before, you will find us in all your favorite social media networks. It looks like we have some problem, but there we are. Instagram, Alquimétricos, as I told you. Thank you very much for being there, for staying with us. For you can ask any kind of questions, and you can make your comments. We have like 12 minutes to go before going. You can make any kind of question you want to know. Perhaps you want to tell us your story and why you were interested in participating here. I will leave you with some funny videos about Alquimétricos. Meanwhile, I will give you the opportunity to say what you would like to say. Hi there.
Hi, Fernando. I have a question. Are any of these open source tools that you're using to build, like the stuff the toys are actually made out of, are these recycled materials? Are these sustainable? What is Alquimétricos' perspective on that?
So, as I was telling before, we have during the past years, we have experimented with lots of materials and lots of let me see. We have experimented with really lots of possibilities. Here you can see cardboard and MDF, recycled plastic, EVA rubber, which is recyclable, actually, another kind of plastic sheet, recycled shoes box, and this very interesting material. This is recycled banner, vinyl banner, which is actually cut by hand or using the plotter, the silhouette light plotter. So there are lots of possibilities. It is a very flexible material, as I was telling you before. It is kind of a relationship games in which each time certain relationships are met, like the elasticity of the material, the diameter of the components, of the holes and the sticks, and everything matches some magical equilibrium, you have a viable kit. And it doesn't mean the material is recycled, it will have like much or better or lower quality. Some kind of, it has to do with those materials characteristics and relationship, and you may be even producing something useful that you can make, you can experiment with and make other kind of tools. And we understand that making a creative learning tool means making things affordable, because in Brazil, in Latin America, like 80% of the population cannot afford a box of Legos. And it actually means you will only have like higher class people studying engineering, because they children, even teenagers, end school without having the actual tools to make your own way in the discovery of what's technology, what's science, and what's arts expression technique in the practice. So we try to make it as affordable as possible, and making it possible to produce kits out of recycled materials with analog tools. It was a solution we find to make it affordable, to make it sustainable, to make it viable. We arrive some communities in which they don't have money to pay for the workshop, or to pay for the infrastructure they need. So we take half a dozen of these tools with us, and we ask them to keep collecting some kind of materials, and then when we arrive, we get all together, and we end up like sharing a template or two. They copy among each other, and then it start getting viralized among the participants, and then that will certainly viralize towards the next school, because some teachers work in more than one school. So it is it's quite a central point in this digital analog fabrication technique, in this high end technology scope. We are that is our north. We make it as simple as possible, but trying to have like there's a creative learning principle that says that for you to have a real creative learning environment, you need like lower floors, like the lowest possible entry barrier, wide walls, so you have a lot of possibilities, a diversity of possibilities inside your classroom, and high roof, because you can grow like a lot. So we really accept and trust the creative learning principles, and the project passion, peoples and play principles. So I think this recycled materials and sustainability perspective we have helps a lot. Which makes it actually it actually enables this to happen in the worst and the most challenging environments we have found.
Is there interest to expand this concept to the West, like in the Americas, like Seattle or LA?
So we are interested in expanding everywhere. Our intention is to go as viral as possible. We are participating in some events in Mexico next weeks. We'll be part of technical Politécnico de Monterrey hackathon that we will be getting. Will be happening in the next weeks, and I had the opportunity to go to Boston in 2019, and it was my first time in the US, and I found I found it an amazing experience, and I think I have a lot to do in the rest of the Americas. I just need some opportunities to get the material there, to share some experience, to book some workshops or residencies, or perhaps a learning program. We have this ready to share in sites in which we try to do things remotely, but at the same time we would like to go live in as many places as possible. So the answer is always yes. Yes, we want. So I think we will be going on with the chat with everybody during the next weeks. I thank everybody, especially the Fab 16 crew, Rebecca, and the rest of the team that allow us to have this workshop, rescheduled because it was a confusion for me. I didn't make it on Monday to my actual timetable. So I thank all the people here who make this kind of event, because this is wonderful. You keep a community growing, and what happened with the maker community during the pandemic is mind blowing. Everybody like was some kind of hero from their living room. So I really thank everybody for allowing us to be here. I thank Scarlett and Thomas to getting near to us during this time. I would like to go on talking with both of you, and I want to give you bye-bye, because this is 3 minutes to go before the Zoom ends. Remember everybody to enter Alquimétricos Instagram, Alquimétricos.com, our community. So I don't find the site. Our site here, Alquimétricos.com. You will see /templates. You will see the blueprints. You can download the vectors, and our site is in English, Spanish, and Portuguese. So thank you once again. It was a pleasure to be presenting at Fab 16 Montreal. See you next year with another workshop. Bueno, buenas noches. Obrigado. Thank you very much to everybody. This is the end of our workshop. See you next year. Bye bye.